Okay. So I'm going to talk a bit about logic today, and for most part this is going to be a practice class, where we're going to practice how to do things. But one of the things that we need to talk about now that you are writing non-trivial programs is to how to make them better. So often you find that writing programs is difficult at first, right? And you kind of start to get used to it, but now your challenge is not to write a program anymore. So now you're past exam 1, your challenge is to write a simpler program. If you find yourself writing hundreds of lines of code, I can guarantee you that most of my solutions are 30 lines or less. So that means you are not making use of some simple stuff, and you are not making use of organization and functions properly. I can tell you most of my solutions for the homeworks, and they are much shorter than yours. It's not like this came to me, like somehow naturally. It's actually, I learned it over years and years of doing the same thing. It's much harder to write simpler programs than writing harder programs. Okay? Longer programs are easier to write. Simplifying is harder. But this is something I want you to challenge yourself to do. Okay? So generally, the first thing we learn is that you're given a program, you have to develop a solution. The second task is that you want to take your code and structure it so that it is easy to read by you as well as other people. That means using meaningful variable names so that the person reading your code, like a beautiful novel, will understand what it says, as opposed to figuring out what the heck is going on in here. It's like, oh my God, I have no idea what's happening, right? So there is an actual natural way to write it, which means having functions that have meaningful names, having variables that have meaningful names, having an organization that most people in the world use and understand. And this is what we are trying to get to you by just continuously telling you to do some things. So structuring is important. You know what is also important? Is testing your code. But testing is more difficult because when you're testing your code, you generally test your code based on what you think it is supposed to do, not what you wrote there. Okay? So basically, you generally never think that you are so stupid to do this kind of mistake, so you just don't check for very obvious things. I guarantee you all my errors are extremely stupid. So debugging and testing requires you to kind of develop a methodology and finding out what are the meaningful things. So when you're testing your code, there are two things you should think. First of all, does your code work for normal things? Normal things that the user can enter. Okay? For the most of this class, we are kind of testing you for normal things because we want you to first get used to that. But the second thing is, can this program break? Can you write the unbreakable program? Yeah? So then you have to think about every possible strange and weird thing that can be done, any input that can be given, and make sure that your program works for all of those. And as you become more and more professional, you have to really test for those also. Debugging is itself a very, very difficult problem. And I think at this point you are getting better at syntax errors. You're finding syntax errors, but more and more frequently you will find semantic errors. So when you do find semantic errors, your problem is figuring out what the error is. And there is not exactly a science, but also kind of an art to doing that. So one of the things that you can do is to first isolate where the problem is. Find a piece of your code and figure out whether it actually does what you think it does. So you can, for example, take a piece of code, put a print statement before and after, but you have to know what to expect and see if it actually starts with the same value you expect and the same value afterwards. To be able to do that, one of the things we suggest is that don't have lines and lines and lines of code, in a single line. Break it into different pieces so you can test each one separately. And if all of those fail, you can use a debugger. And I want to show you what that is. and hopefully some of you will actually try it with me. So we are going to take this program, and we are going to figure out how to do debugging using WinID debugger. So you can see probably some of the things that you can watch for, and hopefully you can use it. If that doesn't help you, go back to your print statements, but when you take upper level classes, it becomes more important to use debuggers. So, one of the things that we are going to do is look at how we can understand something like infinite loop. So this is a very simple program. It reads a number and then starts at 0 and increases I one by one until it reaches n, and then computes the sum. So let's see this in action. So I enter 5, and it outputs sum is 10. If you wanted to see if it is actually proceeding correctly, one of the things that I would do is I would add a print statement right here. I would say print, and you should maybe put a special symbol to show your debugging code that you are going to later on get rid of. So for example, you can print the value of I and the value of sum. So if I wanted to test how I is working, I can actually put a print statement that shows me, as I loop through things, how the value of I and sum is changing inside the loop. So, when I is 0, sum is 0. When I is 1, sum is 0. Because I actually printed this before I added up, right? So maybe I should print this after I added up, so that would be better. But before I change I. Okay, so 0, 0, 1, 1, 2 is 3, 3 is 6, and 4 is 10. It kind of shows me what's happening in my program, right? If you wanted to print one before the loop, you can print it before. Sometimes people actually put explicit things like, for example, debug as a Boolean. So I'm going to print this if I'm debugging. This is kind of conditional program. Okay. Now I know it's working. I can get rid of it, so it doesn't actually print anymore because I set debug to false. Okay. So this is kind of a way of thinking very proactively about testing something. I have a print statement that prints what's going on. Okay. So let's set that one to true. Actually, let's get rid of this for simplicity. Okay. Now, the thing that you care about is what is happening to these variables, right? I have a variable I and variable sum, and what is happening. There's actually a tool that helps you visualize the same exact thing without you having to print everything. Because you can print everything, but that's not necessarily the best way to do everything, because there is already a tool to do that. So that is called the debugger. So have you, by mistake, put a red dot here ever in your program? Yeah? Okay, so let's see what that is. So this is called a breakpoint. It is telling me that when you put a red dot there, it tells me that execute your program up until you come to that point. And when you come to that point, stop for a second. And then at that point, you will have the option of executing your program one line at a time or executing the whole thing. Okay? So if you run like this, the breakpoint has no effect, right? If you press this green button. But if you run with this, red bug here, it says continue or start debugging, then it's going to execute a little differently. So you can see that this is actually now at the debug IO. I am actually in the debug mode. And I entered the value 5 because that was before my breakpoint. And then it's going to reach the breakpoint and it's going to stop. So now it's waiting to execute that specific line. It only did read n and initiated sum to 0, I to 0, and n should have value. What should be the value of n? Come on, cooperate. 5, all right. It turns out you can see what those are by going into this thing called stack data. This is basically all the variables that your program has. Since my program has no functions, local and global are the same. If it had functions, when I'm executing a function, that will be local, and whatever is in the rest of the program will be global, right? But currently there is no function, so global and local are the same. Now let's look at slightly carefully. So there is a / doc, which actually is the description of your program, okay? Currently it has no value. You know where that value comes from? The documentation for your program? It comes from this first line that you can put that I keep telling you. So like testing. Well, we'll look at it. Let me finish this part first. Testing the infinite loop. If you do not have that as a tool, what you can do is go to this bar here. Are you here? Okay, so go to this bar and double click, okay, or right click, and then do insert tool and insert stack data. If you don't have it, you should be able to insert it to either the bottom bar or the left bar. Okay, so let's start again. So I'm going to do 5, and I'm going to go back to stack data. You see the doc is actually now this information right here, right? So this is actually what's called the doc string. It's the definition of your program. And this is where the program is stored as a file. And this is the current name of this program. Whatever you are executing is always called main. Okay? So inside a program, whatever you are executing is the main. But in addition, you may actually have other code that you import, right? Those will have different names. But this is going to become important in a second. Then here you have 3 variables. You have I, you have n, and you have sum. N is 5, I is 0, and sum is 0. Okay? So now I can step through my program one by one. So I can go one step at a time by clicking this. So when you go in like this, it just means step into this specific program. Okay, so I executed one line. It checked, is I equal to n? No, because I is 0, n is 5. They are not equal. So now it's waiting to execute this specific one, which is sum I plus 1. Sum is 0, I is 0, so sum is going to be 0. Then it's going to increment I. Again, I'm clicking on this one. And now you can see that I actually became 1. And the next thing it is waiting to do is to execute while I is less than or equal to n. So I is now 1. 1 is not equal to n. So I'm going to execute again. So now I'm going to add it to sum. I has become 2. While loop still not false. So I'm going to add it to I. Now sum is 3. And still not equal. Okay. And as you execute, eventually it's going to look at I and n are now the same. So the while loop is actually going to stop. And then it is going to do the print. And then here you go. This is what the output is. Okay. Yes. So I don't know, because people have different Wing IDEs, and in fact, I messed up the one on my desktop, and I was not able to play with it very well. So, so if it's not working out, let me try to work with you after the class, okay? Because I don't have a single answer I can give you. I have messed it up and was unable to get it, but I recommend that you actually right-click and look and see if you can do this. I know that most of you have top and bottom, whereas I like left and right, but it should work the same way. Okay? So here's my question to you. When will I have an infinite loop in this program? Will this program ever have infinite loop? Yes. When? I is negative because I start at 0, I keep incrementing, right? If I start at 0 and incrementing, it's never going to become negative, right? So you can test that, okay? Don't do this because I know that if you do this, your program kind of dies. But if my first number is -1, and I is 0, and I keep incrementing I, but it will never be -1, right? So it's not doing anything, it's an infinite loop. But one of the nice things I've recently learned is that if you press play again, if it's not frozen, it actually goes back to the beginning. So what would happen if we do the same thing with debugging? Okay. Now I'm going to press this one again. So I'm going to do -1. Okay. And I'm going to go to stack data. Now here, it's not like a magic tool where you will immediately see. You have to actually engage with what is happening. But if you were to do this many times, you will see that I keeps increasing, and sum is increasing, but I is becoming larger and larger, whereas n is still -1, and they will never be the same. The nice thing about the debugger is that it never is officially an infinite loop because you are actually not executing it all the way. So you can actually catch it. So this is one of the things that you can do instead of a print statement, because the print statement doesn't really solve the whole problem. But if you wanted to, you could also do this. What you would see is that I is continuously increasing, sum is increasing, but nothing much is happening. Okay? So this is not really going to tell you what your problem is until you realize that it will never be -1. But anyway, so I want you to kind of start to get engaged and try to use these tools. And if you have not figured out how to do it, bring it up here at the end of class and I will try to show it to you. I'm not guaranteed to figure out for every one of you, but I'll try my best. Okay. So this is step 1. Step 2 is this thing that we just saw. The name. So in Python, every single part of your program is actually an object. So if you think about it, you have many different kinds of objects in your program. So let's write that down. So one of the main objects in your program is actually the variables, right? So all your variables are objects. And you create variables in the global, and sometimes you create variables in the functions. Similarly, the functions themselves are objects in Python. Now with functions, you can do multiple things. You can print functions, even though that's not a very useful thing, but some of you have accidentally done it, right? Yes? So you can print functions or you can execute functions. Clearly, what we care is executing them. And ultimately, your program is an object. And your program itself has, for example, attributes that you can print. So, for example, one of the attributes that we saw was the documentation string, right? So you can actually bring the documentation string. And generally, the things that belong to your program is underscore underscore. So underscore underscore doc underscore underscore. Another thing that your program has is an attribute called name. And the name itself is basically a value that it takes when you execute it. When you execute it, it's always a string that is called main. When you import it, it can be anything that you import it as. So if you import, for example, homework for util as u, then / name will actually be /u. Now, why is that relevant? It is relevant because it allows you to distinguish the part of your code that runs when you execute your program, but that will not execute when you actually import it. Okay? I know that this is kind of a subtle thing that it will take you a while to do, but the reason why we are introducing now is that every single programming language you will ever use actually has a specific function called main, and Python doesn't have it, but this is Python's version of implementing it. There was a question in the back. No? Okay. So because of that, from now on, we are going to start to write our programs in such a way that distinguishes between the functions and the main part of the code. So think of your program as follows. So you have basically a doc string, which explains the program. And you have your import statements. If you are importing anything, let's import random. I'll talk about that in a second. Then you must have all the functions that are going to be used. Okay. Now, what kind of functions are needed? I don't know yet, but we are going to actually talk about them and then think about them. And then you have the actual thing your program does. That part I'm going to put under a condition. That looks like this. It says that for my program, if the value of the variable main is equal to the string main, do the string that comes right after this. Okay? Okay? And I'm going to save this. Now, why do I put it under here but not here? What will happen? Nothing will happen because the print hello will always print, right? So this is hello 1, this is hello 2. I mean, there's nothing wrong with having this. But if you were to actually import, let's save this, import drunk2. So in the same way you import your program as a code, it is not going to execute the second one because this part, when I import my program, this part is actually not true anymore because, in fact, my program is now called drunk2. Whereas this part is always executed because it's actually above the if.name part. So what we are going to ask you to do from now on is to have your program in such a way that everything that your program does, all the important code is under if name.main. Okay? So let me try to do a simple example and then work through how to really create this. So what I want to do is write a program that basically has some drunk person, which of course never happens on college campuses, walking on a platform, and we want the drunk person to randomly go left and right, okay, until eventually he falls off the end of a platform. Okay, so randomness is very important. How many of you are game major here? How many of you play games? How many of you are playing games right now? All right, not cool. All right, so a lot of things are based on randomness, but unfortunately your program is never going to be fully random, okay? There's actually an algorithm that produces numbers that look random, but starting from the same point, they will always produce the same sequence of numbers. But to get some random numbers, we call them pseudo-random, there is in fact a module called random. Well, you have to first import it. Once you import it, if you call random.random, it will give you a random number between 0 and 1. And it's completely uniform distribution. So every number is equally likely. If you wanted to generate numbers between 1 and x, you can also do that, but you have to generate random integers between, let's say, 1 and 10. There we go. Okay. So you can use both numbers. Random returns between 0 and 1. Random returns between two numbers. Yes. 1 is inclusive, yes. 3 arguments, yeah. So okay, we will see why that is, but I believe it is inclusive. But that's a good question. Okay. So what we are going to do is write a program, and I'm going to think about the main steps of the program. So think about your program as, what is it going to do initially? What part is it going to repeat? And what functions do I need to help do the same thing? Okay, so what I want is read the length of a platform. This is what my function I want to do. Okay, and I'm going to put the trunk in the middle of the platform. And then I'm going to print the platform with the man in it. Okay. So now I'm going to basically have the guy going left and right, okay, randomly, until what happens? Until he falls off, right? So this is going to be a loop, right? So while the drunk is still in the platform, randomly move the drunk, print the platform, and that's it, right? So what I've written is kind of an outline of what my program does, right? And it doesn't really have too much of a detail, but it at least tells me what it does. Now, when you're writing programs, your main job is to make sure that most of your code, the thing that is under if name is equal to main, is kind of small. Something easy to see, right? I can see basically what my program does. In fact, very often I do error checking, whether my input is valid and so on in that part, unless it's a very complicated error checking. So basically, this is what my program does. So let me try to see if I can write most of that. And then I'm going to decide which functions can help me do this better, right? So I am going to have a platform. I'm going to read it from the user. Then I'm going to put the drunk in the middle of it. So I'm going to have a variable called location, and it is roughly in the middle of it. I don't really care so much that it is, not exactly, it's integer division. Okay? Then I'm going to randomly find something. So if you want the guy to randomly move left or right with equal probability, you can get this random number. If your number is less than 0.5, let's move him left. And if it's greater than 0.5, let's move him right. Okay? So this is a very simple way of kind of doing randomness, because if all the values are equally likely, I'm going to get values all over the place. 0 is inclusive, 1 is not, so they are very unlikely. So I'm going to put 0.5 to be the midpoint. So if my values are less than midpoint, I'm going to go one way, otherwise I'm going to go the other way. So this is kind of making sure that I go equally in both directions. If I wanted to go more to the right and less to the left, I can change my value to be greater than 0.5, then I would go to the left, right? Sometimes you play a game. I play this game on my iPhone. It's called Two Dots. So often I play the game, and I feel like, it's not like I'm playing the game, but the game is playing me. Because the point of the game is for me to play the game, right? So if I succeed immediately, it's not going to be great. But if you make it so difficult, then you're not going to play a long time also, right? So you have to kind of win every now and then. So they actually adjust the randomness so that I actually win every now and then. I really don't think there's any actual skill involved. So anyway, so that's what I'm going to do. So I'm going to check while the location is greater than 0 and less than or equal to n, meaning that I am still inside the platform. I am going to get a random number. Let's call this next. Let's call this next. So random.random returns a number between 0 and 1. So if next is greater than 0.5, I'm going to go to the right. So I'm going to increase location with 1. Else, I'm going to decrease the location with 1. Okay. Now, all of this is good, but what is the thing that I'm not doing? So I am moving the drunk left and right, but I'm not actually printing where it is, right? So what I'm going to do is I'm going to put a print statement. So now the printing the platform is kind of complex. Maybe that part I'm going to put it in a function so I can call it over and over. In fact, this way I can also test it easily. So I am going to basically write print platform location n. Okay? So basically I have kind of written my program, except that I have to figure out how to print the platform and the person in it. But outside of that, my function is very easy. Okay? So I can just write def print platform. So in fact, I can give these better names. This is the length of the platform, that is the location. So I'm going to see how many to the left and how many to the right, right? So you have length minus location. Hopefully this is not negative. Should not be negative, right? So length minus location to the left, and how many to the right? So if I have, let's say, 20, I'm at 0.5. No, this is actually location minus 1 to the left, and length minus location to the right. And I have no idea if this is actually correct. We will do this in a second. So I am going to print this many left and then an X, which is where the person is, and then some to the right. Okay. Now, if you don't know if this is actually correct, okay, what you can do is you can just put your thing here, and then you can test it, okay? Because I really don't know if I did this right. So I'm going to test it with, for example, the guy being at location 1, okay? This is at location 10. This is at location 5. Does it more or less look correct? There's a plus and 1 problem, but all right, I'm going to not care too much. And I'm going to put a little input here so that this is not going to run endlessly. So basically, I can actually continue doing this. Okay. So let's try and see. So this is how I'm basically doing, right? So I did 10, and the guy is in the middle. And now, did he move left or right? Left. Okay, left, left. Move back. So one thing that I see that the raw input is actually on a new line. How do I make it on the same line as the print? I think that if I put a comma here, it thinks that I'm at the end of that line, but there is not a new line, right? So let's see if that works. So now it's actually printing in the same. What if I want to figure out how many times I've executed, the number of iterations? So now I need to figure out how many times this actually goes on. Does he actually fall off? Is it happening? Oh. Is he falling? No? Do you think he will eventually fall? Oh no, there you go. Now I decided that I want to add the number to the beginning, okay? And this is something that I want you to continuously think. Okay, if I want to figure out how to print which iteration this is in, what I'm going to do is I'm going to have a new variable. I'm going to call that iteration. And I'm going to add this to my function. And I need to keep track of it here. So when I first start my program, my iteration is 1. So I can actually add it here. And every time I execute, I'm going to increment the iteration by 1. Okay? And then I need to actually print the iteration. So I'm going to print the iteration by this. Okay, like this. It looks okay, but probably I should put a space right here too, right? So I can put that right here. Now I'm able to see how quickly it finishes. Do you want to see it bigger? So I'm going to get rid of this, and I'm going to do it with a bigger number. Let's say it was 40. It's going to take a lot longer for him to reach it, right? Oh, because I did not actually do this. There we go. Is it always the case that it's always left? No. Okay. So this is what we are trying to tell you, how you can structure your program. That you have a description of it, you have an import, you have a function. Your function only uses things that are in its arguments, and that everything else, the main part of your program, is a short piece of code that is easy to read. Okay? And starting with homework 5, I want all the programs to have this if name is equal to main thing, and hopefully you will actually one day use it. Okay? So, with that, we are going to go back and do some exercises of Boolean logic. Now, Boolean logic itself is not very difficult, but using it is very difficult. Okay? There's a whole class on logic. You will take logic if you take foundations of computer science, and you will master logic throughout your career. Okay? So what we are going to do today is write more complex statements. But there are two interesting things that are going to become more important. So when you write very complex statements, go back to the truth tables. Now, the truth tables themselves are kind of easy to remember, but they are not foolproof. Okay? So basically, the AND means that when you have an AND condition, both two parts of the condition have to be true, or all parts of the condition have to be true, which is fine. Okay? And when you have an OR condition, at least one of them have to be true. And when you have a NOT condition, it basically simply negates true or false. So a couple of things that we haven't had the time to go through, so I'm going to refresh you on a few things. So you do know that to check for equality, we use equal, equal. To check for inequality, you use not equal, that is written like this. You can compare numbers by less than or equal to. But you can also compare strings with less than. Now, the string ordering is a little challenging because it is a combination of computer logic and human logic. Okay? So, when you compare individual letters, it is alphabetical ordering, right? A comes before B is alphabetical ordering. Okay? How about AA and AB? Alphabetical ordering? Yes. Okay. How about AAC to AB? Okay. How about this? So the rule is that this is called lexicographic ordering, which is basically the ordering that you would find in a dictionary if the dictionary itself was a thing that you would look at physically, which you basically just look it up on the network now, right? But if you actually looked up a physical dictionary, dictionary ordering works as follows. Which is called lexicographic ordering. So, first of all, it is alphabetical ordering. So, if you have multiple letters, it's up to the letter that they differ. And for example, A, B is less than A, B, A, because you compare up to here and AA comes before ABA, right? If you have the same exact string, like AAA and AAAA, okay, so they have the same prefix, then the shortest one comes first, okay? So shortest first. But there are a whole bunch of other things that are ordered that you should really not care about, but you will and keep asking me, because there is also ordering among other things. So, for example, is there an order between letters and numbers? Apparently there is. Is there an ordering between lowercase and uppercase? Yes. Do I care? No. The point is that, this is because they are actually stored. There's an ASCII code for all of these, and that's really what the ASCII code is for that specific character, but it really doesn't matter because it's not logically meaningful to order with respect to casing, okay? So as far as I care, when I say order, I just mean lexicographic order, and generally we don't care about case, and we will make that clear, okay? So that being said, now we are going to try to do some more complex conditions, okay? So when you have much more complicated conditions, you end up with things that are combinations of ands and ors. So, for example, you may have, and I'm going to use A and B for conditions. So, for example, A and B, or C and D, okay? So if you write a condition like this, read this as follows. It says that either this condition should be true or this condition should be true. Of these two, if this is true, both A and B should be true. And for this to be true, both C and D should be true. But there is actually a very simple way you can also look at this differently by distributing one over the others. So you can take this one and distribute it over others, like you would do in math. This is called the De Morgan law. So you can actually represent this as A and B or C, and A and B or D. Okay? So what I did is I took this and distributed over these two. So I have the or in here, and this and goes to here, right? This or goes to here and here. You can continue further by distributing this C or these two. So I can now make this as A or C and B or C and A or D and B or D. Okay? So it turns out that this condition here and these conditions are the same. Which one is more readable? The first one? Well, it depends, okay? And we will see that in a second. And you can do this. This is the distribution of the law. The second law has to do with the negation. So if you have A and B, okay, and you take the negation of this, not, what I can do is I can negate every single element in that condition. So this is the same as saying not A. What is the negation of and? Or not B. Now, if you were to do the truth tables, they actually turn out to be identical, right? So you had A and B. And if you did not, and then you took that and you did the not, right? So if you had, I will do one, but then we will move on. So you have A and B. So you have true, false, false, true, false, false, true, true. And if you have A and B, only this is true, these are all false. Okay? Hopefully I have not messed this up, but not A, and this is not B, right? So not A is false, true, true, false, true, false, false, true. No, so this is true, false, true, false, right? Okay. So what is not A or not B? So this is not A or not B. Is this is true, 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 and false. Okay. What is the not of this? Which is this whole thing is the not of A and B, is in fact true, 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 and false. Okay. Now, why I'm torturing you with all this? Whenever you are writing a complex condition, you can look at it in many ways. Okay? So sometimes it's easier to look at it using a positive way. Sometimes it's easy to look at it using in a negative way. So we will do two examples. Okay? And believe me, they are difficult for me too. Okay? Now, let's write a Boolean expression to determine if two circles intersect or not. So I would like to figure out if I have two circles. So circle 1 is at x0, x1 with radius 1. And so this is circle 1. And circle 2 at x1, x0, y0, x1, y1 with R2. I want to figure out if these circles intersect or not. How would you find out if the circles intersect or not? Okay. So now if this becomes difficult, don't worry. Anybody who does this the first time has seen it before. Yes? Okay. Whenever you're given a problem like this, always think about this. When do they not intersect? Let's find a case where they don't intersect. Yeah? Yes? I heard the correct thing. Did you hear that? So what I can do is actually I can check if the distance between the radii, the centers is, so this distance here should be less than R1 plus R2, right? So if I wanted to write that function, it will look something like this. So if I have x0, y0, r1, x1, y1, r2, first I need to find the distance between x0 and y0. So I'm going to have to import math. So I'm going to take x0 minus x1 square plus y0 minus y1 squared. Okay. And if distance is less than or equal to r1 plus r2, I'm going to return true, else I'm going to return false. How about How about we order semesters? This is something that I do it wrong every time. I want you to tell me a semester given as a semester and a year, which one comes first? So is spring 2013 spring 2015 comes before fall 2015? Spring comes before fall? Yes, okay. So spring 2015 comes before fall 2014? All right? So let's write that condition together then, okay? So I want to check if semester 1 is less than semester 2. Okay? So I am going to have S1Y1 and S2Y2. I'm going to use semesters as couples. Okay? So I'm going to send things like is bigger, for example, fall 2014, spring 2014. Okay. Okay. So if I'm doing this, what is the first thing that I need to check? Okay. What's the first thing I need to check? Well, do I care about the fall and the spring if they are not the same year? Do I care? So if one year is smaller than the other, then that one is? So if y1 is smaller than y2, then I should return? So let's do find bigger. Okay. So if y1 is less than y2, then semester 2 is the bigger one, right? Okay. If, what's the next thing I need to check? If y2 is less than y1, then I want to return semester 1 because that one is bigger. How about if they are, if both fails, then what do I have left? They are equal, okay? In this case, what do I check? So here, what are my options? If they are the same year, what are the options? Either one is fall, the other one is spring, or they are the same, okay? So I can check either way. So else, if S1 is equal to fall and S2 is equal to spring, then I need to return. If they are the same year, fall comes first. Fall is bigger, right? Else, what do I return? They're both the same, right? I can return any one of them. So here I would put a note. They are the same, return any one. Okay? So you can actually test this by printing the values here. Okay. Oh, this should be semester 1 and semester 2. Semester 1, semester 2. Okay. So once you have tested it, you should test it the other way too, and then you see that works. Now, what if I was ordering 3 things? I actually wanted to find out who is the biggest among 3 values. I want to return who is the biggest value, who is the second value, who is the third value. Okay. So I want to return, for example, if A is less than B and B is less than C, I'm going to print, okay. Now, how can you possibly do for any combination of values? This is where things are going to get a little bit more interesting because there are many different ways that A, B, and C can be ordered. So let's try to figure out how many ways A, B, and C can be ordered. Okay, this is where triple quotes will be useful. So they can be A, B, C. They can be A, C, B. These are the 2 options where A is the first value, right? Then B can be the first value, so you can be BAC and BCA. Or you can have C as the first value as CAC and CBA. Now, you can write this in writing in all possible orderings. So, for example, we can write every possible way they can be ordered in my if statement. If A is less than or equal to B and B is less than or equal to C, then I'm going to write this. Don't forget the equals. And if now I actually have what I need to test, right? A is less than or equal to C and C is less than or equal to B, then I am going to print A, C, B. Right? And you can write every possible ordering, but you cannot skip any one of them, right? Because every single one is the same. Now, another thing that you can do is you can group these if statements by basically in this way. Both of these if statements have what is in common. A is the smallest value, right? So instead of writing it in this way, I can try to actually group it in a slightly different way. Okay? So, and I will tell you that I will most frequently do this very wrong. So, don't assume that I'm going to do this correctly. So, first I'm going to look at A is the minimum value. Okay? So, I can say something like A is equal to minimum of A, B, and C. Right? That works. So I know A is the smallest value. Now all I care is B is less than C or not, right? So if B is less than or equal to C, I'm going to print ABC. Else, I'm going to print A, C, B. Okay? Now this is slightly different. What I've done is I actually now divided my if statement into 2 parts. The second if statement is actually one level inside. So I'm going to execute this statement if the top part is true. Okay? You have to be very careful, right? So I had 2 conditions. If A was the smallest, then I needed to care about between B and C, right? Now, if I write else here, right, this is an else of the top part. For example, I can care about B being the minimum value. In this case, I care about if A is less than or equal to B, C. I can print now B, A, and C. Else, I'm going to print B, C, A. Because I know that the first element is now a B, all I care is the ordering between the rest. Now, in the last part, I don't actually have to do the same thing because I know that A or B are not the minimum value. So in this case, C has to be the minimum value. Now all I need to do is, in fact I'm going to write this, C is the min value. All I need to do is I need to check between A and B. So I know that CAB and so which one is the more efficient one? Okay. This is a difficult question. There are many different variables, especially when it comes to Python. Okay. In this one, you are ordering every single value. So every single if statement requires you to check two conditions and an and. Whereas here, as soon as you fix this, if A is not the minimum, you are not even going to check these. You've skipped over all of these if statements. And if B is not the minimum, you're also going to check this and only going to check this part. But it's not super easy because to find the minimum, you actually have to compare A to every single one of them, right? But since this is Python, actually minimum is a very efficient operation, so most likely this will be more efficient, okay? So this is one way we have ordered a more complex if statement and broken them into smaller things. Now, which one do you find easier to read? 1 or 2? Okay. Well, we will see a little bit more about this when the next lecture comes, and then we will continue refining our operations like this.